Reginald the alpaca and Jocelyn the alpaca are madly in love with each other. If one masses 73.49 kilograms and the other one masses 47.6 kilograms, what is the force of attraction if Reginald is in San Francisco and Jocelyn is in Buenos Aires, which is 6,464 miles away? Now you'll notice that I've made miles very bold, and actually that's a hint. This is a distance, but it's a distance in miles. Now it's pretty critical that we need it to be in meters. So I need some dimensional analysis. So to go from miles, there's 1.6 kilometers in every 1 mile. And then for every 1 kilometer, there are 1,000 meters. So that means 64 times 6464 times 1.6 times 1,000 equals divided by 1 divided by 1. Now, my calculator gave me a very long standard notation, 103.42400 meters. Now, I can leave it like that, or I could write it in scientific notation. To be honest, it's not terribly long. I'm just going to write it in scientific notation. Okay, I know the mass of Reginald is 73.49 kilograms. I know the mass of Jocelyn is 47.6 kilograms. To be honest, if I goof these and switch them, it really doesn't matter. And then I know G is 6.673 times 10 to the negative 11. The thing that I'm looking for is force due to gravity, and that's going to be in newtons. And the formula, according to Newton, is force due to gravity equals this constant G times mass 1 times mass 2 all over distance squared. So the force due to gravity equals G, which is 6.673 times 10 to the negative 11 times this quantity, the mass of Reginald, 73.49 kilograms, times the mass of Jocelyn, 47.6 kilograms, divided by the distance, 103.42400. Yep, I did that right. Okay, but I need to square it, and that's really important, the squaring bit. So I'm going to solve the top of the parenthesis. Force due to gravity equals 6.673 times 10 to the negative 11 times quantity 3498.124 over the bottom and that is 1.069652378 times 10 to the 14. And so force due to gravity equals 6.673 times 10 to the negative 11 times, when I solve the parentheses, I got 3.27033 7235 times 10 to the negative 11. Giving me a grand total force due to gravity of 2.182296037 times 10 to the negative 21 newtons. And if I were to make that pretty in my class, I would say 2.18 times 10 to the negative 21 newtons, or 2.18 e negative 21 newtons.